Hey guys, welcome back to Civil Learning Online YouTube channel, and let's continue our lecture on Inverse Laplace Transformation. So here I have got some different type of numerical based upon the Inverse Laplace Transformation. Whenever we are solving any kind of numerical problem based upon the Inverse Laplace Transformation, we have to look into the denominator first. So as you can see here, the second portion of this linear factor of the denominator is in the form ax square plus bx plus c form. So here it is quadratic type, and let's learn how to solve this kind of numerical problem. So without any further delay, let's get started. So we have write down solution, and we have 1 upon p plus 1 times p square plus 2p plus 2 is equal to a upon p plus 1 plus, I hope you remember what we used to do in for quadratic fraction. What we will do, we will write it as bp plus c times p square plus 2p plus 2. Now what we will do, we will do the solution, and before that we have to do the cross multiplication with the denominator. So we have on RHS we will have 1 equals to a times p square plus 2p plus 2 plus bp plus c times this, and this will get cancelled out, so p plus 1. Now if p equals to 1, if we take p equals to 1, then what we will have, if p equals to minus 1, so that it will get cancelled out. So if p equals to minus 1, on LHS we have 1 equals to a times, on RHS we will have minus 1 square means 1, and 2 times minus 1 is minus 2, and plus 2 plus this portion will get 0 because p is minus 1. So minus 1 plus 1 0, and 0 multiply this portion will get 0. So we will have the value of a as 1 equals to this and this cancel out, so a equals to 1. We have got a equals to 1. Now what we will do, we will do some calculation to calculate the value of b and c. So from equation 1, let this be equation 1. So from equation 1 we will have 1 equals to, right here now 1 equals to a times p square plus 2p plus 2 equals to plus, and bp is multiplied with p, so bp square plus bp, so b times p square plus p, okay, plus c times p plus 1. How this became c? Here we are going to multiply this both with bp, okay, and with this both with c also. So this is what we got, c times p plus 1 and bp times p plus 1. So p times p square, and p times 1 is p. Okay, now we will compare on both sides to find the value of b and c. So we have got that a equals to 1. Now if we compare the value of p square, constant of p square, so here nothing means 0 times p square plus 0 times p and plus 1. Okay, so we have for p square means a, on RHS we have 0 equals to, on LHS we have 0 equals to RHS, on RHS we will have a times p square means a and plus b, and we have got the value of a as 1, so 0 equals to 1 plus b, and from here we have b equals to minus 1. Now we have got the value of b. Now we will need to find the value of c. So for calculating the value of c, we need to compare, let's compare for the constants of p. So constant of p is c, on RHS we have 0 times p, so 0 equals to, and constant of p is going to be 2a 2 times a and then p, so 2a, and again constant of p is plus b and constant of p is plus c. So we have 0 equals to 2 times 1 is 2 minus 1 plus c. So from here we have c equals to minus 1. Now substitute the value. So on substituting the value, we have on substituting the value we have 1 upon p plus 1 times p square plus 2p plus 2 equals to a means 1 upon p plus 1, and inverse Laplace transformation of this portion is equal to inverse Laplace transformation of 1 upon p plus 1 plus inverse Laplace transformation of b means minus 1 times p, okay, and c is again minus 1 by p square plus 2p plus 2. So we have inverse Laplace transformation of 1 by p plus 1. Inverse Laplace transformation of 1 by p plus 1 is e to the power minus t plus take minus 1 common, so this is minus, and from if we take minus 1 common from this both, so we will have minus here and p plus 1 inverse Laplace transformation of p plus 1 by p square plus 2p plus 2. Now we will do some minor calculations. We have p plus 1, so write this p as p plus 1 plus 1. We are splitting so that we will get some concrete value to drive it into the formula. So we have inverse Laplace transformation of p plus 1 upon p plus 1 whole square plus 1 square. This is a plus b whole square formula, a square plus 2ab plus b square, okay, and this plus 1 is written as 1 square. So now we have the formula, we know the formula, that is e to the power minus t minus p plus 1 means e to the power minus t times p upon p square plus a square. P upon p square plus a square is sine at, a in place of a we have 1, so sine t. So we can take e to the power minus t common, so on taking e to the power minus t common we have 1 minus p upon p square plus a square is cos t, so we have 1 minus cos t, and this is final answer. Let's see one more example based upon the partial fraction, and we have the quadratic equation in the denominator. So here it is the second numerical problem, and write down the solution here. And if we have a close look to our denominator, this is also in the form of ax square plus bx plus c, and this is also ax square plus 0 times bx, okay, plus 0x, okay, means 0p, that is the same thing. This is also quadratic and this is also quadratic. So how we are going to solve this? See here, write down solution, and 2pq plus 2p square plus 4p plus 1 upon p square plus 1 times p square plus p plus 1 is equal to, so for quadratic we will write a p plus b upon p square plus 1 plus cp plus d upon p square plus p plus 1. Here this portion also quadratic, this is also quadratic, so in case of quadratic we do this type, okay. Now we will do cross multiplication. So on doing the cross multiplication we will have here 2pq plus 2p square plus 4p plus 1 equals to ap plus b times p square plus 1 gets cancelled out, so we will have p square plus p plus 1 plus cp plus d times p square plus 1. So from here we will have 2pq plus 2p square plus 4p plus 1. Okay, is equal to, now we will multiply these three terms with both. So we are doing the multiplication now. So AP will multiply these three. So we have a pq plus a p square plus ap plus bp square plus bp plus b plus cpq plus cp plus dp square plus d. Next we have 2pq plus 2p square plus 4p plus 1 equals to, now take commons. So for the coefficient of pq, it is going to be a plus c times pq, and for a p square we will have these three. So plus a plus b plus d times p square plus, for p we will have 1 2 3. So for p we will have a plus b plus c times p plus, for without any variable, that is b and d, so b plus d. Now we will compare on both sides to equate and find the value of unknowns, and a b c d are unknowns here. So for if we compare for the value of pq, we will have 2 equals to a plus c, comparing these two. Similarly for p square, let's compare these two. For p we have 4 equals to a plus b plus c, and we have a plus c value, that is 2. A plus c equals to 2 plus b. So from here we have b equals to 2. We have got the value of b. Now we are going to use the value of b. So one more thing, we have b plus d equals to 1, b plus d equals to 1 on comparing both sides, and we have got the value of b equals to 2. So 2 plus d equals to 1, so we have d equals to minus 1. Now use the value, we have got the value of b and d. Again we have a plus b plus d equals to 2. For comparing the p square value, we have 2 equals to a plus b plus d, and we have the value of b and d. So a plus value of b is 2 and value of d is minus 1. So from here we will have a equals to 1, and here we have a equals to 1. Now we have got the value of a, b and d. Now put the value here, that is 2 equals to 1 plus c. So from here we will have c equals to 1. Now rewrite the equation and do the inverse Laplace transformation. So we have here inverse Laplace transformation of 2pq plus 2p square plus 4p plus 1 upon p square plus 1 times p square plus p plus 1 equals to inverse Laplace transformation of ap plus b. A is 1, so p plus b is 2 upon p square plus 1 equals to, plus inverse Laplace transformation of c is p plus d is minus 1 upon p square plus p plus 1. So after calculating the value of a, b, c and d, I have written it as inverse Laplace transformation of the question equals to inverse Laplace transformation of a. In place of a we have the value, that is 1, plus b value by p square plus 1 plus inverse Laplace transformation of p plus cp plus d, means c value is 1, so 1p minus d plus d value is minus 1, so minus 1 upon p square plus 1. Now what we did, we have separated the numerator into two different portions, and we have p upon p plus 1 plus inverse Laplace transformation of 2 times 2 by p square plus 1. So 2 can be written as 2 times 1 upon p square plus 1, and 2 can be brought here, so that we have the formula 2 times inverse Laplace transformation of 1 upon p square plus 1, which formula is 2 times sine t, and here we have cos t, and here we have inverse Laplace transformation of p minus 1. So p minus 1 can be written as p plus 1 by 2 minus 1 by 2 plus 1, because these two are equal to even putting both here it is 0, and we have done this step so that we can bring it into some formula. Here it is p square plus p plus 1. P square plus p plus 1 means we can we have to bring this in the form of a plus b whole square formula. So a square plus 2ab, 2a square plus 2ab plus b square. Okay, so here we have 1 plus 2 whole square, and we have to subtract the same value what we have added. So we have added 1 by 2 whole square here, so we have subtracted 1 by 2 whole square, and this plus 1 is as it is. Okay, so and if we have numerator in numerators some addition, we are going to have a plus b to the whole square, so we have to we must have same value in addition with p in the numerator also, so that we here we will be able to apply some formula in the form of exponential. Okay, that's what we have done. So we have p plus 1 by 2 and minus 1 by 2 minus 1 is minus 3 by 2, and here numerator we have p plus 1 by 2 whole square and minus, and we have solved this minus 1 by 4 plus 1, minus 1 by 4 plus 1 is minus 3 by 4. So minus 3 by 4 can be written as root under 3 by 2 whole square, and that is what we have done, minus root under 3 by 2 whole square. Now we will solve this further. So we have here cos t plus 2 sine t plus, we can separate these two as inverse Laplace transformation of this much portion, okay, this much portion, and minus inverse Laplace transformation of 3 by 2 and this much portion. See here how. Let me write one more step here, and that is inverse Laplace transformation of p plus 1 by 2 by p plus 1 by 2 whole square minus root under 3 by 2 whole square minus 3 by 2 times inverse Laplace transformation of 1 upon p plus 1 by 2 whole square minus root under 3 by 2 whole square. Okay, so here we have cos t plus 2 sine t plus p plus 1 upon p plus 1 whole square minus root under 3 by 2. So p by p square minus a square, p by p square minus a square. First of all, we have to do the Laplace transformation by shifting theorem, second shifting theorem. So we have e to the power p plus 1 by 2 means e to the power minus 1 by 2 t times p by p square plus a square. P by p square minus a square is cos hyperbolic at. A means root under 3 by 2 t, and minus, see here we must in order to apply the formula for sine, we must have a upon a square minus p square minus a square, and here we have p plus 1 by 2, so e to the power minus 1 by 2t again. Okay, second shifting theorem, and e to the power minus 1 by 2t minus, and we have to bring here root under 3 by 2, so that we will have a upon p square minus a square, because here a is root under 3 by 2. So in order to do that, we have to we can write 3 as root under 3 times root under 3. Root under 3 times root under 3 is 3. Okay, and this 2 is brought here, this 2 is brought here, so we have to eliminate it from here. So we have now a upon p square minus a square. Okay, so we will have here root under 3, this root under 3 is here. Okay, and minus sine, and this is minus, so sine hyperbolic at means root under 3 by 2 and t, and this is our final answer. You can also take these two common, and we will have in bracket cos hyperbolic root under 3 by 2 minus sin hyperbolic root under 3 by 2. That is up to you. Our solution, this is our final answer. And I hope you understood this lecture. See you in the next video. In next lecture we will discuss about something new. Till then, stay safe and take care of yourself.